Intro Algebra Lesson 1-2A. We're going to be speaking about powers and exponents. So to start with, I'm going to kind of go over this diagram here. I've got a giant 4 and a smaller 3 to the top right of that. The giant 4 is what we refer to as a base number. The exponent is the smaller number that's up and to the right. We don't want to write the exponent top left. It always goes top right. This entire thing normally would not have a circle around it. I just put it there to say that this entire situation is what we would call a power. And the way it works is that this number here, this base, is going to multiply times itself that many times. So the exponent tells you how many times you should multiply your base together. For example, that 4 to the third power really means 4 times 4 times 4, because there are 3 factors of 4. Then when you multiply it, 4 times 4 is 16, and 16 times 4 is 64. So the actual value of 4 to the third is 64. Number one mistake, the absolute biggest mistake made with exponents, is people just multiply. And they go, oh, 4 times 3? That's 12. No, it's not 12. Because that would mean 4 plus 4 plus 4. And we are multiplying those bases. 4 times 4 times 4. So you must be very careful about that. This is your base number. The exponent tells you how many of the bases will be multiplied together, times themselves. All right? If we try some of these out, express the power with numbers and variables. All right? So with both. Our first one, 8 to the first power. So 8 is your base, and the 1 is the exponent. And that 1 is saying you have 1/8 being multiplied. That's just 8. I know that 8 times 1 makes 8, but that's not what we're doing. We're not multiplying the base times the exponent. Don't do that. 5 to the second power. 5 times 5. That's what that would actually mean. If we wanted to take it a step further and evaluate that, we could say 25. But if we're just evaluating it or expressing it right now in terms of numbers, we could get away with 5 times 5. 7 to the third power. Again, that's not 7 times 3. That's 7 times 7 times 7. So we are expressing this with numbers. We're not actually evaluating it. We could take it a step further if we wanted to, but we're not doing that right now. 9 to the sixth power. So that's going to be 9, 9, 9. That's only 3 of the 6. 9, 9, 9. We have now expressed this power in terms of the numbers, the base numbers being multiplied out. All right? If we said r to the nth power, we don't really know what n is, and we don't know what r is either. So we have no real way of expressing this other than to say r dot 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 r, and then maybe under here we could say n factors. But because we don't have the actual values, we can't say how many of those r's there are, how many r's there will be. This n represents the number of factors. If we suddenly were told, oh, by the way, that there's 7 of those, n represents 7, then we could write 7 r's. If somebody said there's 13, n equals 13, then we could write 13 r's. But at this point, we don't know, so we just write down that there's n factors as an unknown. Alright, now we want to evaluate. And if you recall, we discussed evaluating. That's where we actually find the value of what it's worth. What would the actual values be worth? The expression of x to the 5th when x is equal to 4. So this is the expression right here. The expression. But we want to find the value when x equals 4, so that's going to get plugged in there. So we replace the x, substitution property, and we say 4 to the 5th power, which means 4 times 4 times 4 times 4 times 4. And we multiply that out. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 gets a little bit harder. What I try to do is I try to think of the 64 as a 60 and a 4. Hopefully I can multiply 4 times 60. That'd be 240. Then I'll multiply it by the leftover, 64. 4 times 4 is 16. So I had the 4 times 60 was 240, plus another 16 makes 256. Then I got to multiply the 256 times another 4, which isn't always easy. But I might be able to double it and then double it again. I know it sounds complicated, but 256 doubled is 512. And then another 512 would be 1024. Now, of course, you could multiply this with a calculator. You could multiply it out using longhand with your paper and pencil. Hopefully, you would still come up with the 1024. Write the expression in exponential form. So now we're going to take an expanded set of numbers, and we're going to see if we can rewrite it using the exponents. So c to the 9th power. Remember, just like we talked about the diagram, there was a base number, and the whole thing is raised to a power. All right? So if c is being raised to the 9th power, we're probably going to say that this is c to the 9th power. C is the base. The power, or the exponent, is to 9. R times R. What value is the base? The base is R. How many R's are being multiplied together? 2. R squared. R squared would mean that there were 2 R's being multiplied together, which is exactly what we have here. 4 cubed. Now, this is a different word. Not everybody knows what that means. It basically represents 3. Because a cube is a 3-dimensional object. Whenever we find the volumes of different shapes, we always say that the units are cubed. So this represents 3. 4 cubed is going to be 4 to the 3rd power, which again does not mean 12. Y squared. Something squared represents 2. The area of this rug would be determined in square yards, or square feet. So squared represents 2, just like a square is a 2-dimensional flat object. This is a 2-dimensional smartboard. So we would say y squared. Now this problem is a little bit tricky looking. There's only 1 3, but there's a whole bunch of d's. There's 1, 2, 3, 4, 5, 6 of them. So since there are 6 factors of d, we could say this is 3. There's only 1 3. And then d to the 6th power. There are 6 d's, but only 1 3. If somebody were to put a 1 on that 3, it really wouldn't make a lot of difference. It means the same thing. And lastly, 2g times 2g times 2g times 2g. Now you'll notice this is really, the whole thing is being multiplied times itself. So you could say, well, there are 4 of those, making 2g to the 4th, because it's that group times that group times that group times that group. So it's the whole group, 4 of those, being multiplied together. If somebody wrote this, 2 to the 4th, g to the 4th, it would still be okay. It would still be the same answer. But you've got to be careful. I'll put an added one up here. Oops. This, if I were to make up another example, if you saw f plus 2, f plus 2, f plus 2, you're going to have to say, well, there's 3 of those, which means, in parentheses, f plus 2 to the 3rd power. Now, unlike up here, you could not say f to the 3rd plus 2 to the 3rd. That will not work. All right? No, I know we did it here, but that's because it was multiplication inside. And we'll discuss that more further. But because it's addition, you cannot distribute or give that 3 to both of those. You would be stuck at this point right here. That's as far as it would go. So that's kind of a bonus question there for you.